Good morning. Today we would discuss about robotic welding, automation, mechanization, etc. To begin our class, we will just see what exactly are the requirements for automation or mechanization to be carried out in normal welding process. The demand for high productivity, the shortage of skilled labor, not only with regards to welding but also with regard to fitter, grinding, etc. There is acute shortage of skilled labor because most of the laborers are interested in doing are getting upgraded to white collar jobs. So the demand for skilled labor is there globally, and also the stringent requirements for safety and health. Uh, as a matter of fact, as we progress day by day, the conditions for betterment of the workmen has to be improved. We have to take utmost care with regards to the safety as well as to the health of the workmen which we debut for work. There is a requirement not only from our side but also statutory requirements are there, several organizations like ILO, International Labour Organization. A lot of these organizations are coming up with uh, latest requirements which demands more, actually it demands a lot of improvement in the working site, as well as in inside ships as well, where we know the conditions inside ship would be like restricted movement, there will be restricted number of entries and exits. There will be restrictions in the illumination possible, restrictions in the ventilation possible, so on and so forth. And also not only due to the improvement requirements of productivity, the shortage of skilled manpower and safety, but also the economics aspect as well, which I have not mentioned here. Everywhere we are trying to optimize, we are trying to get the optimum output, thereby increasing the profit. So in order to understand what exactly we do by mechanization or automation, we need to understand what are the various stages associated with welding. Say for example, a preliminary operations like the the grinding, then that means the edge preparation, then cleaning of the rust and all may be still done manually, but to an extent it can be automated as well. Whereas the major stages starts with assembling the parts by tack welding or by using jigs and fixtures, number one. Number two will be assembling. The assembled part shall be then presented for welding, like in front of a welding torch or a welding head, or the welding torch or welding head shall be brought to the assembled piece. That means present the assembled parts of to the welding head or vice versa. Then we have to initiate the weld by striking an arc and then switching on the current, and then actually we start the arc. I mean, the welding commences. But in order to proceed, we have to impart a relative motion. That means the welding torch has to move over the weld joint or over the designated joint. That means we have to start the welding process. The welding arc has been started in the previous stage, but now we have to start the welding process. The relative motion has to be created between the welding head and the workpiece at a desired welding speed. We have to control the welding speed as well. The motion, whenever there is a motion, there will be a velocity or a speed, and that shall also be controlled. Otherwise, we will not get the desired welding output. And then not only with regards to striking arc and then the imparting a relative motion, there are various welding variables which are associated with welding, like current, voltage, arc length, oscillation of the arc, then lot many parameters like the electrode tip distance, then lot many variables are associated with that, and all those variables shall be controlled in order to get a sound weld. And once the welding is over, we have to stop the relative motion so that the welding is stopped and then the arc shall be is switched off. After the welding is over, we have to shift the piece to away from the welding torch and then we'll bring in a new welding piece or a assembled piece for commencing the next welding. So there is another motion of the workpiece associated. And then the last is the removing the completed work. So basically there are 8 different stages associated with welding other than the edge preparation and cleaning. That means assembling the part, then the presenting the assembled part for welding, initiating the arc, starting the arc, where the variables to be controlled, stopping the arc, shifting the welding head and removing the workpiece. And different types of mechanization or automation associated with welding will be like, let us start with manual welding. In manual welding, all the 8 stages which we have discussed shall be done with the human hand itself. Whereas in stage 4, where we do the relative motion, in certain cases we can depute a welding carriage or an automatic, not an automatic, a mechanized method for movement. So even if that is the stage 4 is slightly mechanized, it comes under the manual welding category. The control of the welding variables are done entirely with human interference. In semi-automatic welding, you can see the stages of the control of welding variables to an extent can be done automatically. Say for example, when we have discussed about MIG welding or GMAW or FCAW, I have told that the welding via speed and the welding via feed is done automatically, and to an extent the control of the current as well as voltage is also done automatically. Not the entire welding variables are controlled automatically, but certain welding variables can be controlled automatically. In that type of process, we call it as a semi-automatic welding process. Even in this case, similar to manual welding, the relative motion can be done with the aid of a mechanization. Automated welding. Here in automated welding, at least the stages like relative motion, the arc initiation, and the control of welding variables shall be done automatically. So if we go back to the stages which I have discussed, stages 3, 4, 5 and 6 shall be done automatically. Only then we can call it as an automated welding. Not fully automated, but automated. Fully automatic, not fully automatic, but automated. The minimum requirements are relative motion, the arc initiation as well as control of the welding variable shall be done automatically. In automatic welding, this consists of controllers. These controllers will have control over the wire feed, the shielding gas flow rate, the power carriers like the current, voltage. In turn, it will also have a small control over the arc length as well as the travel speed. So what happens is that these controllers will have a certain inputs and output mechanisms to control the travel speed. The travel speed would be like there would be some wheel associated with it which will be electronically controlled with the controller, and then the power source will have certain connections with the controller so that the required current and the required voltage can be adjusted as per the requirement. That the wire feed is not a very complex thing. Even in semi-automatic process we use that wire feed. It basically depends on the simple volt, the volt current carrier. I think I had discussed this in class 1 or 2. And then the shielding gas flow rate can be adjusted with a small actuator. The main cost associated with the automated or automatic welding is with regard not only to the controller but also to the complex jigs and fixtures associated with it to hold the workpiece in a particular position. So these jigs and fixtures are actually needed, and it needs to be accurately positioned as well. Otherwise, if it is not oriented or positioned properly, it will naturally affect the quality of the weld produced. This will also have certain limit switches and timers to control the movement of the arc as well as the sequence of the welding. These are basically used for high volume industries where we have a repetition of shapes, a repetition of the products which are produced. Whereas if you just see about the low volume things, it may not be that ideal. That is because those may need custom made designs, and for this fabrication of custom made products, dedicated jigs and fixtures may also be needed, which actually will be very costly affair. So this auto, actually I am very sorry, the title should have been automated welding, not automatic welding, in for this particular slide, because automatic welding we have not discussed. We were discussing about automated welding. I'm very sorry for that. Just consider this as automated welding. In automated welding, the major welding processes that can be automated are SAW, ESW, GMAW, FCAW, etc. This is an example of how automated welding is performed. Here in the left you can see a complex pipe which is fixed, and then welding is performed automatically. And in the right also we can see certain jigs and fixtures at the floor which fixes the plate onto a particular location, and then welding is performed. Here the welding the operator is trying to I think he's trying to it's and the welding has not started. I think he's just guiding the torch to the seam. I mean, a minor adjustments are being made. It's actually a automated welding process, and here the welding has not actually started. The figure may be slightly confusing, but um, the operator I think is trying to position the shielding gas torch. Other than that, I don't think he is doing something here. Automatic welding. In automatic welding, all the 8 stages which we have discussed shall be done without the aid of any operators or human interference. Even the final ejection of the completed product is carried out mechanically without any manual intervention. That means the entire process is done automatically. The operator need not continuously monitor the work operation itself. Here, as we see, it actually needs a lot of programming. It needs a computer, it needs a programmer, and even a seam tracking unit or adaptive controls, which we will be discussing in the subsequent slides. Here it's more or less similar to a CNC machine, where I think you might have seen the operation of a CNC machine. The entire thing will be automated. The only thing we have to do is we have to give a program, and you see these things are developing day by day with the advent of in this artificial intelligence, Internet of Things. The automation has become more what do you call flexible compared to early maybe 10 years back. So a computer is needed, programmer is needed, and the adaptive control unit is needed. And we will be discussing from here onwards much in detail about automatic welding as well as robotic welding. So let us start with the adaptive controls. Adaptive controls are like seam tracking unit is an adaptive is an example of an adaptive control. Here the adaptive control performs two functions basically. The first function is to ensure that the welding torch is moving in the desired direction, as well as the other function is to ensure the quality of the weld produced. There are basically 4 types of adaptive units. Like one will be spring loaded, the other would be electromechanical devices, the other will be slightly more complex like arc sensing units which can control the arc voltage. And then comes the latest technology of optical adaptive controls. These optical adaptive controls will have further 2 types like video camera assisted optical adaptive controls, and then laser beam tracking optical controls. So let us start with spring loaded. Spring loaded, you see the idea is very simple. You will have a weld groove over which the welding has to be performed. there will be a spring assisted wheels over the groove, so that it's just like a train. Like the train, there will be a rail, and the rail will the wheels will be guided over the rails. I mean, wherever rails will be there, the wheel will move over the rail. Similarly, over the groove, the wheels will be positioned, and the wheels will move only through the groove. Just similar to the welding, movement of a train. So spring-loaded things will have spring-loaded wheels will be positioned. But you see, the advantage is it is very good for horizontal as well as for vertical, whereas it will be in a straight line. But whenever there is a curve, the wheel can move over the curve, but the torch motion may not be as desired, because when there is a twisting, the torch will also get repositioned, but that repositioning may not be exactly as per our requirement. And coming to the second thing, electromechanical devices, these depute very small or very light electronic probes, and these particular probes will detect the seam, and then adjust the position of the torch accordingly. The main problem associated with electronic probes is that these are very sensitive to heat, and during welding, a lot of welding heat will be produced, and this particular heat can damage the electronic probes. So these are still used, but the limitations are we need to change the probes frequently because of damage due to the heat incidents. And then comes arc sensing using arc voltage control. This will have a mechanism to oscillate the arc and interpret the variation in the arc area to sense the join locations. The main problem associated with this, it takes some time to interpret and then program and then adjust the torch and to position it over the groove. The main problem with this is the speed of the programming would slightly be slow. So whenever we need a very high travel speed, this may not be as efficient as it is required. And then coming to the optical adaptive controls, it is a very complex, as well as very though it is complex internally, it's very user friendly. Like, it uses a computer system. It can either use a computer system to program the optical data which is got, and then the programming is then transferred to the welding torch, which adjusts the motion according to the output of the program. So it can either be a video camera as well as a laser beam. This laser beam are the latest technology. I will show one picture of the laser assisted seam tracking. This video camera will provide very accurate movement, but the problem is that it is affected due to the smoke or the fumes which are produced due to the welding. To an extent, it is affected due to the heat as well. You see, here we can see a laser assisted seam tracking. There will be a laser which actually have a slight offset, so that the movement of, you see here, before the welding is performed, what happens is that the machine will just move through the joint with the laser and then reconfirms whether the position of the welding torch is correct, and some minor adjustment are done automatically, not with the aid of a machine, with the aid of an operator. And then only welding is performed. Here the picture has been taken during one such process, where the movement is done initially with the laser assisted seam tracking, and then the trailing torch will be trailing the laser, and then welding is performed. The adjustments of the arc length, etc., the current, voltage, everything is done automatically, and then the welding is performed. Here what we can see is, you see the welding torch will always trail the seam tracker. To the right of the welding torch, you can see an electronic probe, like a syringe, which actually detects the seam track, and then the program is then transferred to the welding torch to adjust its position. Partial or complete replacement of manual work by any equipment can be considered as mechanization. The degree of mechanization can even be performing some isolated functions also, and for fully mechanization also. I mean, the entire operation can be carried out with the help of a machine. So that is what we mean by mechanization. Whereas in automation, the machine is also able to bring in and bring out the material. You see, the motion of the workpiece is not a simple thing. Though we are doing it manually in most of the cases, you just imagine how we can program the movement of the workpiece automatically. So that's a very complex thing. So when that is also done, we can say that automation has come into picture. In automatic welding, the positioning of the parts to be assembled on the welding machine and their removal when the welding is completed with the aim of program machines. And mostly we use numerical data for its function. The benefits, as I have already discussed, will be increase in productivity, economics, change in working conditions, and social consequences, which I have discussed when I told about the ILO, International Labour Organizations, etc. Now we will be discussing a further step ahead, that is known as flexible automation. We have been talking about automation, automated, semi-automatic, etc. But this is actually the area where we have to pay attention in future. Like a numerically controlled or computer controlled program in flexible automatic welding replaces the complex fixturing and sequencing devices. So that's what I was telling. These jigs and fixtures, which I have discussed before, it's a very costly affair. This can be replaced with numerical and computer control programs, so that only very minimum requirements of ensuring the position of the workpiece is actually needed. Also, the welding program can be changed to accommodate even small load production of several designs. Whereas when we were discussing before, the flexibility for designing a new product was restricted due to requirement of very costly jigs and fixtures. The small volumes of similar parts can be produced automatically in a very short time. Flexible system can be also reprogrammed very easily for designing a new product or fabrication of a new product. Flexible welding automation can be interfaced with automatic manufacturing operations, other operations as well, not only with regards to welding, but like a milling or a lathe or a turning operation. And the next particular thing which we are talking about is flexible automation is not complete without mentioning about robot. So this robot, industrial robot, is the most flexible of the automated systems used in manufacturing process. Robotic welding is actually a variant. It comes under the automated process and is the best flexible automated welding or automated process, not restricted to welding, but it is an automated process, flexible automated process. These robots can be programmed to perform any task under the automatic programmed control. There are basically two types of motions associated with robots. The first one would be articulated and the other would be rectilinear. Articulated means it would be hinged, it can have motion in all the 6 axes, which I think you will know. I will discuss about slightly in detail in the coming slides. So that would be, the one type of motion would be articulated. Articulated enjoys the freedom of degrees of freedom of almost all the degrees of freedom it can have that motion. Whereas in rectilinear there is a restriction in one axis movement. A robotic workstation is a combination of various equipments integrated in a single control. The combination of the equipments will be integrated, means all the functions will have a integrated control, and then the programming will be done such that all the controls are interconnected. A typical station would be having a robotic arm, robotic work positioner, a welding process package, and a fixture. A fixture is not as complicated as the fixtures which we were mentioning for simple automated processes. Naturally for welding, the robotic arm will carry the welding gun. Then the robotic welding can also be programmed to trace the welding path, which is a welding seam. This can be done. This is normally done with optic devices recently. The robots are programmed by moving the welding torch along the weld joint it is also not that complex, but it will become complex based on the geometry of the workpiece which is deputed. The positioning signals are sent to the robotic controller where they are recorded and where they are stored, and the robotic controllers can also set this way. This thing I think we have already discussed. Then there would be a robotic controller. The robotic controller will be controlling the power source, will be controlling the wire feed, will be controlling the relative motion, will be controlling the motion of the welding torch also. The main issues associated with shipbuilding is that we are building very large and complex steel bolts. The tolerances would be very high, and there's a possibility. The advantage is that there's a possibility that 100% CAD application is possible. 5 or 6 axis lightweight robots are used with gantries. These are the most ideal things, which I have told. All the 6 axes are possible, like the motion in the 3 axes, then the rotation over the 3 axes. This is an example of an articulated robot, which is used for welding. Then coming to the, do you know what is a seventh axis? So seventh axis basically means the parts are transferred along the linear path. As a result, the vibration created when the parts are rotated are eliminated. That means whenever the parts are getting rotated, there would be certain vibrations associated with it. So that can be actually prevented. The 7 axis robot has its own dynamic control to coordinate all the 7 axes to ensure the optimum speed, accuracy, and the lifetime. So, having said this, I think that is enough for you people to understand about automated welding processes as per your curriculum. Actually, it's a very wide topic for discussion. So, I think we'll wind up with this, and we'll come up with a new topic in the next class. Thank you.